Hi everyone, today we are going to discuss expansion using Maclaurin series part 2nd. In part 1st we discuss expansion of e to the power x. So what is the formula for e to the power x? So that is equal to, this is 1 plus x square upon 2 factorial plus x cube upon 3 factorial plus x raised to 4 upon 4 factorial plus and so on. If we write nth term, so in this way, plus x raised to n divided by n factorial plus and so on. This is called as exponential series of e to the power x. So this is called exponential series. Exponential series. Now in this formula we have to replace here. After replacing simply x by minus x, and we have to getting the new series expansion of e to the power of or power is a minus x, so e to the power minus x, so that can be written as, so what is the formula here? We have to getting if x is replaced by minus x, so what we will get here? So 1, next term is a minus, plus x square upon 2 factorial, means here replacing x by minus x, so that will becomes positive x, so means x square divided by 2 factorial. Next term we will get here x cube divided by 3 factorial. Next term we will get x power 4 upon 4 factorial plus and so on. We have to getting that this series expansion. Now after that, also suppose this is exponential form of e to the power x. So also if we are to replacing again x by minus x, or here this minus x by here x simply. So I am replacing x by ax. So what is that here? E to the power ax. What is series expansion of e to the power ax becomes, that is a 1 plus ax plus a square x square upon 2 factorial plus a cube x cube upon 3 factorial plus and so on, plus a raised to n x raised to n upon n factorial plus and so on. So this is a e to the power ax series after replacing x by ax. Now second formula we discuss also here, series expansion of sine x, or we have to know what is a sine series. Sine series means, what is that here? Sine series means which series? We have to getting expansion of sine of x, and sine of x you know very well. Sine of x, what is the expansion of sine of x? So this is x minus x cube upon 3 factorial, plus x raised to 5 upon 5 factorial. Next term minus x raised to 7 upon 7 factorial plus and so on. So this is sine series expansion we have to discuss in earlier session. Now after that we have to also discuss formula number 3rd, that is a cosine series. I am writing here again sine series. Number 2, what is a sine series? Means sine x is equal to, that is a 1 minus, that is a, I am writing here x minus x cube upon 3 factorial plus x raised to 5 upon 5 factorial minus x raised to 7 upon 7 factorial plus and so on. So this series contain, what is that? Odd powers of x with plus or minus alternate sign. Odd powers of x with plus or minus alternate sign. So this is called as a sine series, guys. This is called as a sine series. Now after this formula we have to also discuss what is the formula for cosine series, means cosine series. So I am writing here cos x. So what is expansion of cos x? So let's see. So expansion of cos x can be written as, this is what? This is first term is 1 minus x square divided by 2. 1 minus x square divided by 2 factorial is there, plus x raised to 4 upon 4 factorial plus x power 4 upon 4 factorial. Now next term will be minus x raised to 6 upon 6 factorial. Next term will be plus and so on. So this is called as cosine series. Now after this we have to also discuss formula number 4. Formula number 4 is, what is that? This is expansion of tan x, and expansion of tan x can be written as, this is x plus x cube divided by 3 plus 2x raised to 5 divided by 15 plus and so on. So this is called as a tangent series. This is called as tangent series. So we have to find in part first all these series how we have to getting here by using Maclaurin's series. Now in this session we discuss expansion of Maclaurin series by using here this sine series, cos series and tan series. Means now I'm going to discuss here next point, expansion of cos of hyperbolic x, sine of hyperbolic x and tan of hyperbolic x. Let's see. I'm discussing now here. So we have to find the expansion of sine hyperbolic x. So let's see, I'm starting here. Number 5, expansion of sine hyperbolic x. Expansion of sine hyperbolic x. So expansion of sine hyperbolic x. So you know very well how to solve this. Let's see. We have to getting here the proof of this can be written as sine hyperbolic means sine hyperbolic x, that is equal to, you know the formula for sine hyperbolic x. This is nothing but this is e to the power x minus e to the power minus x upon 2 upon 2. This is definition of sine hyperbolic x. This is the definition of sine hyperbolic x. Now also we have to write here the expansion of e to the power x and e to the power x. Now this is very clearly understanding is there, guys. Clearly you have to understanding is there. Now you know that let series expansion of e to the power x. So what is the series expansion of e to the power x? You know very well. This is a 1 plus x square upon 2 factorial plus x cube upon 3 factorial plus and so on. This is e to the power x expansion, and e to the power minus x expansion, you know very well, this is a 1 minus x plus x square upon 2 factorial minus x cube upon 3 factorial is there plus and so on. So only plus or minus alternate here. Now terms are remain still as it is. Now substituting this equation 2 and equation 3 means substituting equations 2 and 3 in equation 1. So after the substituting we have to getting the equation 1 as this is nothing but this is a sine hyperbolic, I'm writing now this in this way, sine hyperbolic x, that is equal to e to the power x, means it is nothing but this is expansion of e to the power x, means you will have to getting that 1 plus x square upon 2 factorial plus x cube upon 3 factorial plus and so on into there is 1 minus x plus x square upon 2 factorial minus here, now plus and minus alternate is there, minus x cube upon 3 factorial minus x cube upon 3 factorial plus and so on. So this is series expansion of sine hyperbolic x. Now therefore after simplifying what we will be getting here, so this is sine hyperbolic x is equal to, so in a simple way you know that if divided by 2 in this equation and remains the terms as that is x plus x cube upon 3 factorial plus x raised to 5 upon 5 factorial plus and so on. So we'll have to getting this is what we'll have to getting this is a sine hyperbolic series expansion of x, sine hyperbolic expansion of x. Understood this? Let's see. Now we are also going to discuss here expansion of cos hyperbolic x. Expansion of cos hyperbolic x. So how to find out this expansion? Let's see. Let's see. So you know also very known expansion of cos hyperbolic x. So what is the expansion of cos hyperbolic x? So let cos hyperbolic x is equal to, that is e to the power x plus e to the power minus x divided by, here what is that, 2. Now here you know that e to the power x is nothing but that is 1 plus x square upon 2 factorial plus x cube upon 3 factorial plus and so on. S cube upon 3 factorial plus and so on. And e to the power minus x, it is nothing but 1 plus x. Now this is a plus or minus alternate, guys, here plus or minus alternate sign is there. So this is 1 minus x plus x square divided by 2 factorial minus x cube upon 3 factorial plus and so on. So after this taking the values, then you have to, this is suppose equation number 1, this is equation number 2, this is equation number 3. So substituting in 1 of equation 2 and 3, so I am writing equation 1 becomes, so what will becomes equation 1? That is a cos of hyperbolic x is equal to, I am writing now this in this way, 1 divided by 2 into e to the power x. So what is the e to the power x is there? This is series expansion of, what is that, 1 plus x square upon 2 factorial plus x cube upon 3 factorial plus and so on, plus in second bracket you have to write, that is expansion of e to the power minus x, 1 minus x plus x square upon 2 factorial minus x cube upon 3 factorial. Next term will be plus x raised to 4 upon 4 factorial plus and so on. After simplifying, what will get? Expansion of cos hyperbolic x, that is equal to, that is a 1 plus x square upon 2 factorial, plus x raised to 4 upon 4 factorial plus x raised to 6 upon 6 factorial plus and so on. We'll have to getting here infinite series, means we'll have to getting here cos hyperbolic x expansion in terms of x. Understood this? Okay. Now I am going to discuss here, that is a very important expansion by using Maclaurin's series. So expansion of logarithmic series. So I am writing here expansion of, that is a 7th expansion or 7th expansion we will discuss here. This is 7th expansion. So let's see expansion of log of 1 plus x. So this is called as a logarithmic series. So how to solve this logarithmic series? Let's see. So let you know very well, let given function, first I am writing here the how to write the proof. Let's see how to write the proof. Let y is equal to given function, let y is equal to log of 1 plus x. Let y is equal to log of 1 plus x. What is a y of 0? Y of 0 is nothing but it is a log of 1, and log of 1 it will becomes totally 0. Let y is equal to log of 1 plus x, and y of 0 is equal to log 1, and that is equal to 0. Now you know that if y is equal to log of 1 plus x, then we have to write its nth order derivative. Its nth order derivative it becomes, that is dn upon dx raised to n of log of 1 plus x. So how to write this derivative of this term? Now this is very easy. So let's see, by using successive differentiation, log of 1 plus x, this is minus 1 raised to n minus 1, raised to n minus 1 into n minus 1 factorial divided by here x plus 1 bracket power n, So this is expansion of log of 1 plus x. This is expansion of log of 1 plus x. I am writing this again. The formula is now in this way. This is a minus 1 raised to n. This is a minus 1 raised to n. N minus 1 factorial upon x plus 1 bracket power n. Now, or also we have to write, if yn is equal to this, then what is that? Yn of 0. Because in Maclaurin series, we have to write the series at x is equal to 0. So yn at 0 means what is that here remaining is minus 1 raised to n into n minus 1 factorial and divided by x is 0, 1 raised to n is nothing but n. So putting here, after that we putting n is equal to 1, 2, 3, 4 and so on. So what we will have to getting here? So y1 of 0, n is 1, so minus 1 raised to 1 minus 1 0, anything raised to 0, your answer will be 1, and n minus 1 means 0 minus 1, that is minus 1 factorial, minus 1 factorial, it will becomes 1 as it is. Now y2 of 0, y2 of 0, how it will be calculated here? Minus 1 raised to 1 into n minus 1 means 2 minus 1, so it will becomes minus 1. y3 of 0, it will becomes 2 factorial and so on and so on. So therefore you know the Maclaurin series, substituting in Maclaurin series, and substituting in Maclaurin series, so what will get the Maclaurin series? This is f of x, so f of x is equal to, or y is equal to, f of x or y is equal to, so in the form of y, so y is equal to, that is y of 0 plus y1 of 0 means x into y1 of 0 plus x square divided by 2 factorial into y2 of 0 plus x cube divided by 3 factorial into y3 of 0 plus and so on. So you know that after substituting the values, y is nothing but here log of 1 plus x. So I am writing here log of 1 plus x, log of 1 plus x, and that is equal to y of 0. So it is y of 0, it is nothing but it is a 0 plus y1 of 0 means x into y1 of 0. So that will get only x because y1 of 0 is 1, plus what is that here, x square upon 2 factorial into y2 of 0, that will get minus 1, plus x cube upon 3 factorial into y3 of 0, it will becomes 2 factorial, and that is, it is nothing but 2 plus and so on. So therefore log of 1 plus x, that is equal to here x minus x square upon 2 factorial is nothing but 2 plus x cube upon 3 is there, plus or minus is there, plus and so on. So this is series expansion of log of 1 plus x, and plus minus alternate is there guys, plus minus alternating is there. I hope you have to understanding very well, and you have to understood this expansion of logarithmic series. So this is called logarithmic series. Understood this? Now let some remark are there. Let's see. We have log of 1 plus x, right? What is the expansion of log of 1 plus x? This is simply, that is x minus x square divided by what, 2, plus x cube divided by what, 3. Next term will be minus x raised to 4 upon 4, plus and so on. We'll get the infinite series. Now this is a logarithmic series, and it valid only for x lies between minus 1 to 1. This is valid only for x lies between, or what is the range of x, minus 1 to 1. Now in this series, in above series, if we replace x by, minus x, so what will get here? If we replace x by minus x, so what will get here? So this is a log of 1 minus x, that is equal to, that is a minus x square upon 2. Now that will be minus x cube upon 3. That will be minus x power 4 upon 4 minus x power 5 upon 5, and this will get, and so on, will get the infinite series. Now in this way, this is a log of 1 minus x expansion. This is a log of 1 minus x expansion, right? So in this way we have to write the logarithmic series. Now after that we are going to discuss here the next expansion, that is expansion of 1 plus x bracket raised to m by using Maclaurin's series. I am writing here the last point I am going to discuss, expansion of 1 plus x bracket raised to m. So we called it is a binomial series, right? So how to find out this? Let's see what is the proof of this binomial series. Let's see. Here let I am considering y is equal to here simply 1 plus x bracket raised to m. So you tell me y of 0 is nothing but x point is a 0, so it will get 1 plus 0 bracket power m, and that is equal to 1 raised to m, and that is equal to 1. So now we have to write the nth order derivative, yn of, or yn is equal to, if this y is equal to this, then yn is equal to, you know the formula for yn, this is m into m minus 1, this nth order derivative is there, m minus 2, m minus 3, and so on up to here m minus n plus 1 into 1 plus x bracket power out guys m minus n. So now let you have to find here also yn of 0. Yn of 0 means n is a 0, simply n is a, or at a point x is a 0. So formula is nothing but as it is, there is no change in formula. So let's see, so m into m minus 1, m minus 2, up to so on here m minus n plus 1 into x is a 0, that's why 1 raised to m minus n, that will becomes 1 as it is. Now putting here, I am doing same thing in past example we discussed, putting n is equal to here 1 2 3 4 5 and so on. So therefore you will have to getting that y1 of 0. So what is a y1 of 0? N is a 1 guys, n is a 1. So y1 of 0, it is a simply m. y2 of 0, it is simply m into m minus 1. y3 of 0 will get here m into m minus 1 into m minus 2, and so on and so on. Substituting in Maclaurin series, let substituting in Maclaurin series, you know the Maclaurin series is what is that? So y is equal to, this is a y of 0 plus x into y1 of 0 plus x square upon 2 factorial into y2 of 0 plus x cube upon 3 factorial into y3 of 0 plus and so on. We'll get this is infinite series. Now let you know the y is what is that here, 1 plus x bracket power m, 1 plus x bracket power m. So y of 0 is nothing but here 1 plus x into y1 of 0, that is into m, plus x square divided by 2 factorial into y2 of 0 m into m minus 1 plus x cube upon 3 factorial into y3 of 0 m into m minus 1 into m minus 2 plus and so on. So I am now doing the only rearrangement of this step, means 1 plus x bracket power m, this can be written as 1 plus mx plus m into m minus 1 upon 2 factorial into x square plus m into m minus 1 m minus 2 upon 3 factorial into x cube plus and so on. And now guys, this is series expansion of 1 plus x. This is series expansion of 1 plus x bracket power m. 1 plus x bracket power m. I hope you have to understanding this concept, and we have to understanding also expansion of 1 plus x bracket raised to m, that is called binomial series. Is called binomial series, and this is valid also only for x lies between -1 to 1, and this is your proof of expansion of 1 plus x bracket raised to m. Understood this? Thank you.